Hey there, it's Jason Gorman from Codemanship with a video about the testing pyramid. So in a previous video, we looked at the process of continuous integration and continuous delivery. And here is the Circle CI build status page for my project's pipeline there. And as well as being very interested in what the outcome of the build was, and they are, of course, all green. I'm not a man that breaks the build. There's another piece of information that my eye is always drawn to on these build status pages, and that is how long did the build take? Now, if your goal is to be getting fast delivery cycles, fast feedback from deliverers of working software, kind of implies that your builds need to be fast. Your builds take an hour or 2 hours or 3 hours, or I've seen some that take 8 hours, then you've got a major problem. That kind of fast delivery cycle, that fast feedback loop is not going to be possible, and that's going to slow everything down. Your build cycle is a bit like the metabolism of your software development delivery process. The slower the builds, the slower your delivery metabolism is going to be, and you're going to get all sorts of problems. Now, as your code starts to grow, the bulk of the time that it will take to build your software typically, is how long it takes to run your automated tests. So test execution time is a critical component of build time, which is a critical component of the metabolism of your software delivery cycle. Fast feedback loops will not be possible if your builds are slow because your tests are slow. So test execution time is very important. So we're going to talk in this video about how do we optimize our test suites so that they run as fast as possible. And I've prepared a little PowerPoint slide here. Always have a PowerPoint slide prepared, talking about the testing pyramid. So the idea here is that we organize our tests into a kind of a pyramid where the base of the pyramid is made up of tests that run very, very quickly. So if you think of this pyramid as it gets up towards the top, these are the tests that run the slowest. At the bottom, it's the tests that run the fastest. The base of the pyramid should be fast running tests. What kind of tests run fast? Well, I call them unit tests, but let's just qualify that. I don't necessarily mean tests that test one method or one function or one module. I mean tests where everything happening when we execute that test is happening in memory. So there are no external dependencies involved. We're not talking to databases or web services or reading files or any of that stuff. It's all happening in memory. So fast running in memory unit tests in inverted commas. So the base of our pyramid is made up of unit tests. We want most of our tests to be at that kind of level, and each test to be able to execute in just a few milliseconds tops. The middle of our pyramid, well, what's left to test? Well, when we assemble our units, our packages, our components, whatever you want to call them, together into subsystems and have those subsystems assembled into even larger assemblies of components, then we need to check that not only does each of these units do what they're supposed to do, but they talk to each other correctly, that they obey the contracts of their interaction. So we need to do some integration testing as well, but we'd like to do a lot less of that because those tests will run slower than our unit tests because it's not all happening in memory. And then finally, at the top of the pyramid, the least number of tests are the ones that test our system end to end. So maybe, for example, browser-based tests for our web application or that kind of thing. Now, if we want the bulk of our tests to be fast running, we want to be able to test as much of the logic of our system using unit tests. So I'll give you an example. If we want to test that a mortgage repayment is calculated correctly, we could test it with system tests. We could test that through the browser and check that the calculation is done correctly. But that means that all of our logic tests are going to run very, very slow. It's going to take hours to test the logic of the software. So as much as possible, we'd like to test that kind of logic using unit tests. So our unit tests are testing the logic of our application. What do the integration tests test? Well, they're testing the contracts between the components in the application. And again, I'll qualify that. They're testing the interactions that are happening across process boundaries, for example, between web services or between COM components or Corba components or that kind of thing, or talking to databases and so on. And that tests all of the contracts. It tests that all of the things are wired together. They're all talking to each other correctly. And contracts are very, very important. The number of times that bugs appear in software or software breaks because somebody broke their side of the bargain. For example, someone changed their APIs so that all the clients broke. The contracts are very, very important, so you do need to test that. Finally, what's left to test? We've tested the logic, we've tested the interactions between the components in the system that are happening over process boundaries. And what's left to test? Well, imagine we're testing a car that we're building. Our unit tests test all of the individual components, the spark plugs and the nuts and so on and so forth. And then the integration tests assemble those components together into subsystems and check that they work together. For example, the electronics of the car, all the impedances between the different components, all the voltages, etc., they all need to be right in order for those components not just to be correct on their own, for example, for the radio to work by itself, but it's also got to work within the electronics of the car, the electrical system of the car. So we test all of that. And then finally, well, what's left to test? Imagine once we've tested all the components of our car, and we've assembled those components and tested they work together, finally we stick the key in the ignition and we take it for a drive. Did we actually build a working car? So if you've ever heard yourself, well, it worked on my machine, and that's the last thing left to test, which is when we assemble all of this stuff together and then we deploy it into the target environment, did we actually build a working system? So these typically would be a cherry picking of user journeys or system tests or browser tests or whatever you're doing, just to double check that we actually built a car that works, that when we take it out on the road, everything works together. So we might end up with thousands of these unit tests on a typical system, a system of hundreds of thousands of lines of code. In terms of integration tests, we would aim to end up with maybe hundreds of those, so an order of magnitude less, and maybe just a few dozen system tests, just a cherry picking of user journeys, for example, just to double check that when we deploy it into the target environment, everything works together as a complete system in that environment. Unit tests should run in milliseconds. Integration tests maybe hundreds of milliseconds. System tests probably take multiple seconds to run. So you don't want to end up with thousands of system tests, because then you're going to be waiting thousands of seconds for your builds to complete, and that's going to create bottlenecks in your development cycle that will be very bad for business. And I've seen it many, many, many times. I've seen some very large businesses literally brought to their knees by slow builds, slowing the whole development cycle down, which means that their ability to keep adapting and changing their software for the business slows down to a crawl, and then the business ends up on its knees. And I've seen some very big businesses that were essentially killed by slow builds. They might not admit it, but I've seen it with my own eyes. Banks, software companies, retailers, you name it. So we're all, as I said, this dictates the metabolism of software delivery. And in this day when software is eating the world, that kind of dictates a business's ability to keep adapting and evolving and keep competing. So it's a real underlying constraint on the ability of a business to keep up with the Joneses, as it were, stay up with the competition. So it's very, very important, but it doesn't come for free. You have to invest to create and maintain a good shape of testing pyramid with the bulk of the tests run fast. And one of the things you need to think about is the design of your software. The software needs to be designed so that it is more conducive to unit testing. Now let's take a look at some legacy code. We'll be doing a legacy code video next using the same example, but let's take a look at this. Let's get a little preview. So I've got some code here that's for a video library. We've got some logic for pricing our video rentals. We've got other logic as well in there, but we've got some logic here for pricing video rentals based on the IMDb movie of the title they want to rent. So the higher the rating of the movie in IMDb, the more we charge, basically. Now let's think about our design principle. First of all, let's think about modular design. Modules, we say, should do one job, and we're about to find out why that's so important. Take a look at this module, our pricer module here. It's doing multiple jobs. There's the logic embedded there of actual pricing based on the rating. There's some other code here that unpacks the data we need about the video, including the rating, from the JSON that's returned from an external API that has all of this IMDb information in it. And then also there is this code that actually fetches that information as a string over the web. So it's essentially doing three jobs. And what that means is I can't test Pricer or anything that uses Price without connecting to the web service, which means all of the tests of anything in the call stack that connects here one way or another is going to end up being an integration test or even a system test. It's going to run slow. Now, as it happens, I have actually rigged up some tests. Let's take a look. Always be testing. So I have got some tests here. I've got a little test here that once we packaged up this code, uses the jar file essentially to run as at the command line, and it feeds in 3 different IMDb's, one for a high-rated movie, one for a standard rating, and one for or an average rating, and one for a low-rated movie. And we can run that test, and we can see how long it takes. It's going to take a couple of seconds. There we go. So 3 tests. It took a bit of a while to run those tests because it's connecting to the IMDb API over the web. Now, if I had thousands of these tests, I would have a real problem. And there are many teams out there who have thousands of these kinds of tests, either Selenium tests that go through the browser or that kind of thing. And that's a real problem. And what's getting in our way here, if we wanted to change this, is that there is code in here that doesn't belong in here. And we would want to take that code out. So what I'm going to do is I'm actually going to extract this code first of all into its own method. So we're going to start breaking Pricer down. And the first thing we're going to do is extract it into a method. Let's call it fetch IMDb info. Or let's just go fetch movie info. Okay, and that's going to use the IMDb. So we're going to get this code on its own to begin with in its own method. Now we'll talk about testing and legacy code in an upcoming video, but there are people, silly people, who will tell you that if you're refactoring legacy code in order to make it unit testable, you don't need to retest it after each refactoring. I have found that to be a very bad idea. So I'm going to rerun those tests and make sure that I haven't broken anything. That might be quite painful if you're, for example, having to test it manually, but it's better to be safe than sorry. So we got fetched movie info on its own. And this is now doing that one job. Its job is to just fetch that string from the IMDb API. The next thing I want to do is I want essentially to put this in its own object. So one way to do that would be, imagine this object exists. And let's call it movie info class. And now you're probably wondering why I'm doing this. What I'm going to do is a little bit of magic here. I'm going to add this as a parameter. No. As a parameter to this method. So the magic will occur. So it's going to be of type movie info. And we're going to make it a new instance of that. See why I'm doing this in a minute. Okay, and it does that whole refactoring. Let's rebuild and retest. So it needs to rebuild, repackage. So this is quite a long feedback cycle for unit testing, as you can see. So there are all sorts of engineering optimizations I would need to do in order to speed up this cycle of retesting the software. Now we should be able to run tests. Okay, still looking good. Now what I'm going to do is I'm going to move this method to our... let's actually make it non-static to begin with. That was another problem that we had there. But to an instance method, and that it gives me a choice now. I can move it to that. What we're going to do. Okay. And so you can see now we've got this movie info class that does all of that work. Let's rebuild and retest. Like I said, this build cycle, even for this small amount of code, I'm finding it to be a bit of a pain in the you-know-what. And so imagine this was a much larger piece of software and how much of a bottleneck it would be. There's a build time of 5 seconds there. Retest it. And the reason I'm having to retest it, really is because of external dependencies, and I'm having to rebuild and repackage to deal with those external dependencies. Okay, let's go back to Pricer. So now Pricer is using this movie info object, but it's still actually connecting to the web service. So yes, we now have a movie info object that does one job, does that particular piece of work, but we need to make it so that we can swap this with a stub version of that, so that we can actually provide stubbed movie info for our unit test, so that we don't have to connect to the external API. So what I'm going to do is I'm going to introduce this as a parameter. Okay, first of all. And let's just retest that. So you need to be super disciplined with legacy code, but we'll talk about that in an upcoming video. There we go, still working. Now let's take a look at our client code. There's our rental. Okay, still same problem here. Now, because this is a static method and it's happening inside rental. So let's take a look at the code that I'm actually using to test it. So that's the code, that's kind of like my test harness, if you like, in this main method. So what I'm really testing here is I'm not testing the pricer, I'm testing rental. So I need to rinse and repeat this. I need to make price non-static. Let's just go in here and make this non-static first of all. Static methods. When people ask me what's the problem with static methods, this is the problem with static methods. You can't stub them or mock them easily without doing some nasty stuff using things like PowerMock, and I heartily recommend that you don't. Rather, we're going to fix this design problem. So let's make this an instance method. Okay. Going to be a new pricer. That's where it belongs. And if we take a look inside our rental, you'll see now we're using a new pricer. So we're getting somewhere now. Let's rebuild and rerun this. So the first thing that really helps to make units more unit testable is that each unit should only do one job. So the bit of code that actually connects, the code that has the direct external dependency, like my code to connect to IMDb, that is on its own in a place that we can easily test it by itself, or we can substitute it, as we'll see in a minute. Okay, let's just retest. So hopefully this feedback loop is beginning to annoy you as much as it's annoying me. That's kind of the whole point, really. And we do a similar kind of thing here. We're basically going to introduce that as a parameter. And now we're going to rebuild and retest. So now it's actually being passed in from my kind of main method makeshift system test harness. There we go. Build's taking longer now. And we can retest. Let's retest and see. Good, still working, lovely. Now we take a look inside our main method here. So the pricer is being passed into the rental object. But what about if we take a look inside pricer? Yes, that thing there, the movie info object, is being passed in from where? Let's take a look. Being passed in from rental. I think it actually needs to be inside the pricer. So the last sort of bit of a dance I'm going to do here. Go into our pricer. Let's assign that to a field. No, doesn't want to do that. Should be. Okay. You'll see why I'm doing this in a minute, because what I'm actually going to do find this. Okay. See why I'm doing this in a minute. We go to pricer to the rental when it uses the pricer, and then program when it creates. So now we need to pass in our movie info object from the outside. So it's all being composed from the outside. So the second design principle is that not only should our units have a single job, do a single piece of work, but they should be swappable. Their dependencies should be swappable by dependency injection. So they can be, for example, stubbed and mocked. So we could easily introduce a stub here instead of passing in the real thing, and that would make these tests run a lot faster. Okay, let's just rental. So now pricer already has a movie info, so we don't need to do that. And indeed we can remove that parameter from this method because it's being passed in. Certainly is. There we go. It certainly is safe. Thank you. So it's being passed in. Now let's build this and check that it's working. Okay, still quite a slow build. Maven shade taking up most of the time there, I think. And let's retest. Just make sure that it does indeed work. Okay, yeah, it's taken a while to run those tests now. Okay, so there's our pricer. It uses our movie info object, which is passed in from the outside. So it's a bit like Russian dolls. The movie info object is passed into the pricer is passed into the rental, so that when we create our rental objects, that whole call stack is now composed from the outside, what we call inversion of control. So the actual order of the call stack is determined by this client code. It's determined here rather than hard baked into each of those objects in the call stack. And that is absolutely necessary for being able to achieve unit testability. So when we say that something is effectively modular, we often really mean that it is effectively unit testable, that we can replace its dependencies by plugging in new objects that look the same from the outside. So in Java, I could use Mockito. I don't need an interface. But it might be wise, maybe at some point, to extract an interface from movie info and an interface from pricer so that these are much more swappable. But at this point, it's not really necessary because I could use Mockito essentially to create, or I could just extend movie info and override those methods. So I don't necessarily need to do that. But if you feel the need to extract an interface to make it 100% swappable, totally abstract, then you're very welcome to do that. So to get your testing pyramid, it is important that every module only does one job so that you can get one piece of work by itself, for example, one external connection to an API on its own. But it's also important that your modules have dependencies that are swappable by dependency injection so that we can replace modules that have direct external dependencies with stub or mock version or dummy versions of those modules for testing. And there's one more thing we need to think about. So I was a very naughty boy. I've got some other code here that fetches the collection of ratings. So on IMDb, you don't just have the IMDb rating, you have a collection, a list of ratings from other websites like Rotten Tomatoes, for example, and Metacritic. And I wanted to be able to fetch all of those ratings. And what I've done is I've copied and pasted the code that connects to the IMDb API. Now imagine as this code grows and we need to speak to that, we need that information more and more, that I might be pasting this code all over the shop, basically. Which brings us to the third design principle that really does help. If we were to basically replace this duplication of that code, we've still got it somewhere. See, it's in our movie info object there. So it's pretty much an identical replica of that code that fetches movie info. So if we were, wherever we see this code that's been copied and pasted, we will actually replace it or reuse our movie info object, get rid of the duplication. That means that now we would only have one point in the software that actually knows how to do that. Only one part of the code that actually has that direct external dependency. So removing duplication from our code, making sure that our code, particularly code that has direct external dependencies, isn't repeated, that helps us to dramatically reduce the amount of code that needs to be integration tested. So there are 3 design principles that really, really help achieve a good shape of testing pyramid, a really fast running test suite where the bulk of the tests are unit tests. The first principle is that modules should only do one job. So the code to actually connect to the IMDb API, there's a module that knows how to do that, basically. And it only does that. There's no business logic in there at all. There's no core logic. There's just the logic. There's just the code for getting that information. That's all it needs to do. Likewise, the code for unpacking that information can be contained in its own object. The code for doing the pricing can be contained in its own object, and so forth. So if each object only does one job, it's much easier to test one thing by itself. It's also very, very important to remove the duplication. Any duplicate code that has direct external dependencies, you want to remove that duplication so that it's only happening in one part of the code. It's only being done in one place. That also will greatly reduce the amount of maintenance that you have to do. For example, if IMDb changed their API, this is actually a third-party API, but if this API changes, I've got to go around changing that in multiple places. If it's only happening in one place, then it's a much easier job to change that if they update their API. And again, I've seen many teams come a cropper when they're using Facebook API or Netflix API or Amazon Web Services API, whatever, and then some of these companies are notorious for changing their APIs in ways that are not backwards compatible. And if your code is riddled with integration code, then you've got a real problem. And finally, those external dependencies, the objects that know how to connect to external systems, those need to be swappable by dependency injection so that we can stub or mock rather than using the real thing, so that we can test our core logic. For example, we can easily test this pricing logic without actually connecting to the IMDb API. And that means that the bulk of our logic can be unit tested. And therefore, the base of our pyramid will be a very large base. It will be mostly unit tests. So there you go. That's the testing pyramid. It's very, very important. If you do have slow running tests, for example, if you've got tests that are very exhaustive, or property-based tests or something like that, or that sort of thing, then there are quick wins you can do. For example, you can parallelize your tests. So if you've got 1,000 very slow running tests, you can break them up and deploy them onto a server farm somewhere, onto web services or onto the cloud, and just throw some hardware at it. There is stuff you can do, but ideally, you just want your tests to run very fast anyway, because you're also going to be running them very frequently on your own desktop. So even if you can send it to the cloud, that's going to be a major, major operation if you're relying on those long-running tests to actually, as I'm doing at the moment, to retest your code as you're working on it. So every little helps, basically. There you go. That's the testing pyramid. It is a vital, vital topic. It is important that you invest in it. You invest in the architecture of your code to make it as unit testable as possible. And that, as you will see, will pay dividends in other ways. The flexibility we introduce for unit testing just means that our code is more modular. A more modular code tends to be much easier to change, because when we make changes to it, those changes are not impacting large parts of the rest of the code base. So there you go. Important stuff. Lots to think about. In the next video, we'll be talking about legacy code, and we'll be revisiting this example. The source code for this example, you will find in the comments below.